Now let's move to part 2, which is handling missing values automatically. In this part, we write a function which imputes the missing data automatically for you. This function is for linear regression models, and one important point to note is that we are not including categorical variables in our function. However, in the future as an extension, we will add categorical variables for it as well. So before we move ahead, let's take a quick overview on what exactly is missing values. As we all know, missing data cannot be imputed or discarded blindly. So before we proceed further, let us quickly get an overview on the three types of assumptions on the missing value mechanisms. According to Rubin, there are three types of assumptions: missing completely at random, missing at random, or missing not at random. The first one, missing completely at random, says that there is no pattern observed in the variable for the data to be missing. Whenever data is missing at random, data is missing randomly within the subgroups of the entire data set. Whenever data is not missing at random, that means that there is a pattern or a relation between missingness of the variable and the variable itself. If you see the example given below, so basically whenever missing data is missing completely at random is that your dog will eat any homework. But when data is missing within subgroups, then dog eats a particular student's homework. Then whenever there's a pattern, then uh, basically your dog is eating only bad homework for you. So this is how you can remember these three parts. So why are we doing all this? Because if we move forward to our R function, we are going to impute our dataset by considering what kind of missing data mechanism your data is having. So let's quickly jump into our R function. Before we jump into all the mess, we know the rule that there is a threshold beyond which we cannot drop or impute the missing values. So we have a function called threshold test, which basically checks for every column in your dataset what is the percentage of missing values. If your percentage of missing values is less than the threshold, then it is going to drop those columns from that particular dataset. So this function is going to return only those columns in your dataset or your data frame where the percentage of missing values is less than 5. Moving ahead, there's a library called Baylor at Psych which provides a function called little MCAR. Little MCAR is going to do a hypothesis test and give you what kind of missing value mechanism your dataset is going to have. So if your p-value is less than 0.05, then we accept our alternate hypothesis, that is that our data is not missing at random. If you take a look at the treat missing function, we are going to obtain those observations which are within our threshold of allowed missing data. Then we are going to perform a littles test to obtain a pattern of our missing data, whether it is MCR or MNAR. Once we perform our littles test, in order to decide the missing values pattern, we are going into a loop uh, using the p-value obtained to impute the observations in our dataset. If you take a look at the else part, where the data is MCR or MCAR, we use a library called mice. So mice is going to perform imputations for the missing observations in our dataset using several iterations, where here m is the number of times or the number of multiple imputations which it perform. There are different methods using which mice performs the imputations such as PMM, logreg, etc. This method can be passed as a parameter in the treat missing function itself. In the end, this is going to return 5 different columns of imputed observations for our missing observations. The advantage of using mice dataset is that we can directly fit a linear regression model using the function called width and aggregate all the 5 different imputations obtained in order to pool the results and get a complete linear regression fit result for our dataset. Similarly, whenever we are using MNAR, that is, as you can see in the if loop, there's a library called mice MNAR. So this also performs imputations similar to the mice function and directly fits the linear regression model directly with the width function using the different imputed values obtained and aggregates all these results in order to give a better result for your data. Let's have a look at how this function will work.